When does a function get called as 1 function? I'll give you guys a clue. You guys have to figure out when is it called 1. So first we'll begin with an example wherein things are not 1. This is actually called as many to one. This is a definition. We have a relation. It turns out to be a function 2 wherein A divides B for the given set 1 and set 2. A comes from set 1 and B comes from set 2. So why is this called many to one? Is something that you guys have to figure out. Keep this in mind. And this is the same definition, but here the sets will differ. The elements in the set will differ. And we'll have the following output. So what is different about this? This is called as many to one. This is a function itself. That too is a function. This is called as many to one, while this is called as 1. Why is it so? Let me start off with many to one. So when we have inputs, right, and say we have outputs. Now, if I pick up any input and say this is pointing to a particular output, and I pick up one more input that points to the same output, if this happens and more than this happens, that is a set of inputs pointing to the same output, it's called as many to one. So when do we call it as many to one? When we have same or more than one input being pointed by pointing to or is pointing to more than one input is pointing to a single output. That's it, as simple as that. So I have few set of examples that will clear it up. One is your constant function. So I have a constant function which points towards 3.14. That is, if I give any input, I get the same output. So it's a good example of many to one. Next, a polynomial function, basically x square. P of x is equal to x square. So this polynomial function is many to one. Reason, if I want an output of 25, I can give an input of 5, or what else can I give? Yes, also an input of -5. If I give an input of -5, I get an output of 25. So with these two inputs, I get the same output, and so this is called as many to one. One more example, the modulus function. If I want an output of 5, okay, this is your 5, is it not? And this is your -5, 5. That is, for an input of 5 -5, I get an output of 5. While if I give an input of +5, this too gives me an output of 5, right? So for two inputs, I get a same output. Even if I have one such pair, it is known as many to one. Okay, so what is 1 then? Obviously 1 is for a single input, we have a single output. Or I can actually put it the other way around. For every output, there is only one possible input. So one such example is your identity function. F of x is equal to x. Let me show that over here. For an input of -5, I get an output of -5. And if I want -5 as an output, I can't do anything else other than going to -5 as an input, right? If I give an input of 5, I get 5, and nowhere else I'll get an output of 5. And so this is your 1 example. So we have say 3 and 3 and so on and so forth, and so that is a possibility. That's not a possibility. So this is an example of 1. As a definition, what do we have? A function f mapping set x to set y is defined to be 1. If the image of distinct elements of x under f are distinct, that is, for every x1, x2 belonging to x. F of x1 is equal to f of x2 implies x1 is equal to x2. That is, let me explain it this way. If I have two people coming to you or coming to me, they tell that, you know what, we got the same output. They have the same output, both of them. And they tell we used 1 functions. How is this possible? The conclusion is you two gave the same inputs. Right? So basically here they're talking about x1, x2. So we are looking at x1 is equal to x2. This is the funda. So this idea that, you know, if two people tell we are pointing to the same output, f of x1 is equal to f of x2, this implies the idea would be that x1 should be equal to x2. Okay, so this idea we'll be using it to derive actually. But yeah, the idea of 1 is quite simple. So this idea of how do we prove something, we have to make use of this. Just think about the story, it's quite simple. If someone comes to you guys telling that we gave out inputs, we don't know what inputs we gave, but we got the same output. How is that possible? If you ask them the question, was the function 1, if they tell yes, then you tell that you guys gave the same inputs. Right? So now you guys have to pause and copy all of this, and please do try all of these codes. And just, it'll take a second, just try giving different inputs and just keep this in mind. You know, do it and it will help you keep things in mind.